Hi, I'm Paul. We're doing must-know Leetcode interview questions. Leetcode must-know interview questions. Today's challenge is maximum depth of binary tree. We're into the binary tree. We're into the binary tree section of must-know algorithms. This is rated as easy. It is pretty easy. I mean, it's a good introduction to binary trees. The challenge is, given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So in this case, for example, the maximum depth is 3. There's two ways to get that. You can go from 3 to 20 to 15. You can go from 3 to 20 to 7. A lot of binary tree algorithms are recursive because really any node in a tree is a tree. So 3 is the root, or I should say, is the root of a tree. 3 is the root of a tree, 20 is the root of a tree. You could even say that 9, 15, and 7 are the root of a tree, although they don't have any descendants, and it's more common to call those leaf nodes. But how do we figure out the maximum depth of this tree? Well, the maximum depth of the tree would really depend on the maximum depth of these two subtrees. So whichever of the two subtrees has the maximum length, we could add 1 and get the maximum length of the tree that's rooted at 3. Now the subtree with the maximum depth is going to be the one rooted at 20 here. But again, what is the maximum depth of that tree? Well, it's going to be the maximum depth of the subtrees. In this case, they're both 1 plus 1 for the root node. We'll pass that back up, add 1 again, and get 3. Is there another example here? Those are the only examples? All right. So this lends itself to a recursive solution, a straightforward recursive solution. Let's handle, oh, wait a minute. Actually, let me check the constraints here. Is it possible to get a null input node? Number of nodes in the tree is between 0 and 10,000 right here. So it is possible to get a null input, all right? That's an edge case, and we might as well get that out of the way. So if node equals null, we'll just return null. Oh, wait, whoa, I'm sorry. This is the depth. We're not going to return null. We're going to return 0. All right. So next step, let's get the depth of the two subtrees. So int left depth equals max depth of, and if we look at the definition of a node, every node has a value. It has a left pointer and it has a right pointer. So we will get the maximum depth of the left subtree. Okay? I'm just going to copy that. Right depth will be the depth of the right subtree. And we're going to return whichever one is greater. Whichever one is greater, L depth or R depth. That's not right. Max, L depth, R depth. But we've got to add one for the root. Okay. And that's it. Yeah, again, you look at a binary tree. What's the maximum depth of the tree? Well, I don't know, but I know that it's going to depend on whether the right, or I'm sorry, the left subtree or the right subtree has the maximum depth, and so on down the line until we get to leaf nodes. Now, if you get to a leaf node, I know what the depth of that is. It's 1. So then we just come back up the tree and add 1 at each level. And let's run this and see what happens. I can't see it. Compile error. If, oh, whoops, I said node and it's supposed to be root. Okay. Max depth, okay, yeah, I'll keep going here. Root. Root and root. And, all right. Now we've got it. Let's submit. I mean, I don't expect like a really broad range of run times on this because I don't want to say there's only one way to do it, but there's really, everybody does this the same way. It's just a recursive algorithm. So analyze complexity. It is O of n. And memory, is there, where's the memory? Memory should be O of 1. We're not, wow, that's weird. Well, I mean, we're not create O of n. Are we creating new, why is the memory O of n? Oh, I see. Yeah, you know what? Because we're stacking, we get the recursive stacks. Okay, so we're right in the middle on the memory. Okay, that's it. That was an easy one to get started. I know there were more binary tree challenges in the pipeline. Hope you enjoyed it, learned something. Feel free to like, subscribe, comment, and see you next time.